Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqman Hafiz bin Rosle, DE180159. Today, I will present about the final year project 1, which is a design of cascaded multi-level inverter topology for integrated portable power pack application. The supervisor of this project is Professor Madya, Technologist Dr. Asmar Rashid bin Poniran, while the panels are IR Dr. Hisham bin Abdul Rahman and Technologist Muhammad Hafiz bin Ismail. This presentation will be divided into 4 parts, which are the project background, problem statement, methodology, and preliminary result. The first one is the project background. This section will explain about the background of the study, objective, and the scope of project. So what is a portable power pack? A portable power pack is a device which supplies electrical power to users' electrical appliance at anywhere. So this device usually have a various of voltage such as 5V DC, 12V DC, and 240V AC. The wide range of voltage output is important to be used in variety of application. The problem statement is, most of electrical appliances need AC voltage source to work properly. This is why an inverter is required in this power pack system. What is inverter? Inverter is actually a converter that converts from a DC to AC voltage. As you can see here, this is a DC waveform is being converted into AC waveform, which is in a sinusoidal. The problem is, most of portable power pack in the market that produce an AC voltage does not have a quality of waveform. So this is why they use a simple H-bridge type of inverter which will produce a low quality of output waveform and producing high total harmonic distortion, which require a big filter and an efficient inverter. According to IEEE, that the total harmonic distortion for low voltage application is much less than 5%. So what is the possible solution that we can solve for this problem? Which is, we can implement a cascaded multi-level inverter for switching technique. So what is actually the multi-level inverter? The multi-level inverter works by increasing the level of the inverter itself. So the higher the level of inverter, the lower the THD percentage and the filter size of the inverter. The objective of this project are, for the first one is to minimize the voltage, THD and size of output filter of the inverter by implementing cascaded multi-level inverter for portable power pack. Second is to develop a circuit models of the portable power pack system by integration between the buck-boost converter and inverter for a complete system. Lastly, to evaluate the performance of the portable power pack system based on the efficiency of the buck-boost converter and cascaded multi-level inverter. The scope project is divided into 5, which is the first one is the project application is restricted to low power applications such as electrical gadget and low electrical appliance that less than 500 watt. The second is the project will use a typical H-bridge inverter topology to design and develop an inverter. The third one is the simulation system will be running on MATLAB and Proteus. The fourth is the performance analysis such as voltage, current and THD percentage will be ensured. And lastly, comparing the different method to control inverter power and effect on different level of the inverter. Let's continue into part number 2, which is related issues in designing multi-level inverter. So there are a few issues in designing multi-level inverter. So the first one is the integration between the converters, which is where the DC is converted into the AC. So the buck boost is required in order to deliver constant and stable input voltage at the inverter. The second one is the THD. So the THD is the main study of this project. So by applying several methods in controlling the switches of the inverter. The third one is the inverter filter. So the inverter filter is to reduce the harmonic induced by low switching frequency and generate high quality of waveform. Continue to methodology, which is part 3, which is will explain about the full design of the portable power pack system and a design of the inverter. Okay, so this is the complete system of the portable power pack. We have here the TNB, which will supply the battery charger dock, and continue to the Arduino Uno R3, which is an additional features for unlock and unlock the portable power pack from the dock. And we have here the 20 volt SLA batteries, which is 2 units of 12 volt batteries that will produce 5 volt DC output by using the buck converter, 12 volt DC output by using the buck converter 2, and 240 volt AC output which will using by inverter. So the dotted line here is where designed to be focused for this project. So this is the block diagram of complete inverter system. We have here the first one is 20 volt SLA batteries and the buck boost converter. So the buck boost converter is a DC-DC converters which will ensure that the voltage input of the inverter will be constant and stable and connected to the DC link. DC link is a device, simply a capacitor that will prevent the transient from the load side into going back into the source side. Okay, and lastly, and for the multi-level inverter and the filter. This is the flowchart of the inverter system. The first one is we need to identify the required load voltage. For instance, in Malaysia, we use 240 volt AC or 230 volt AC. And then we choose the number of switches used, which is the MOSFET switch, and choose the method to control the switches. So for this project, we have two methods, which is by using the PWM, which is the pulse width modulation, and the SPWM, which is the sinusoidal pulse width modulation. So the PWM is simply by giving the pulse at the switches, while the SPWM is we compare a two signal, which is the reference voltage and the carrier wave, and this is the output of the SPWM signal. Okay, lastly, for this presentation, we'll discuss about the preliminary result. So the preliminary result of this project is simulated by using the MATLAB simulating software. Okay, so the first one, we have the PWM inverter, the 3 and 5 level of PWM inverter. The 3 level of PWM inverter is on the left. We can see that we need at least 4 switches to produce 3 level PWM inverter and 8 switches for the 5 level PWM inverter. Okay, so this is the output of the 3 and 5 level of PWM inverter. To check the level of the inverter, we can simply by looking into the waveform of the inverter. So as example, at the 3 level of PWM inverter, we can see there are 3 level of voltage at the waveform, 1, 2 and 3. And for 5 level PWM inverter, we have 5 level of voltage at the output waveform. So 1, 2, 3, 4 and 5. So this is the PWM inverter parameters and performance comparison between the 3 and 5 level of PWM inverter. Okay, for the 3 level PWM inverter, we need at least one voltage source, while the 5 level PWM inverter, we need at least 2 voltage source, and number of switch for 3 level is 4, while the 5 level is 8. And the main concern here is the THD output, which is the 3 level is 52.06%, while the 5 multi-level PWM inverter producing 29.98%, which is a huge difference between the 3 and 5 level PWM inverter. Okay, let's continue to another method in controlling the switches at the inverter by using the SPWM. Okay, we have here the 3 and 5 level of SPWM inverter. Okay, as mentioned before, that the SPWM inverter required two type of signal, which are the reference signal and the carrier signal. As in the 3 level, required at least 2 carrier signal and 1 reference signal. So this signal will be compared to produce a difference pulse width based on the reference signal. Okay, for the 5 level, we need at least 4 carrier signal and 1 reference signal. So the number of switches is kept the same as the PWM inverter. The above pictures shows the carrier signal and the reference signal, while the below shows the difference or the compared signal between the reference and carrier signal. So on the left is the 3 and on the right is the 5 level of SPWM inverter. So as you can see here, when the number of inverter is increasing, the output pulse will be increasing too. Okay, so this is the output waveform at the SPWM inverter. So the level inverter is also same like the PWM inverter, but we can see the difference is the pulse size between the PWM and SPWM inverter. Okay. Okay, the study is then continued by simulate 7 and 9 level of SPWM inverter. As you can see here, on the 7 and 9 level of SPWM inverter required much more switches and voltage source. This is the reference and the carrier signal, and the below one is the compared signal. Okay, this is the output waveform of the 7 and 9 level of SPWM inverter. As you can see here, at the 9 level SPWM inverter, the output waveform is close to sinusoidal waveform than compared to 3 level of PWM or SPWM inverter. Next is the inverter parameters and performance comparison. between the PWM and SPWM inverters. So on the left, we can see is the level of inverters, number of voltage source, number of switch, and the THD percentage. As we can see here, as the level of inverters is increasing from 3 to 9, the voltage source and the number of switch will be also increasing, but the THD percentage will be decreasing towards the level of inverters. Lastly, I would like to choose the 5-level SPWM inverters over 5 level over PWM inverters, because the PWM inverters will produce 99.9% of THD, while the SPWM inverters will produce 26.84% of THD. So the difference between these two inverters is as much as 10.47%. So the reason why I will not choose the higher level of inverters, as the higher level of inverters, like 7 or 9 level, will consume more switches and voltage source. So this is not practical to be used at the project, because the higher of level inverters will consume more cost and increasing in complexity of circuit configuration. Okay, I think that's all for the presentation. So thank you for spending your time with me. And if you have any question, you can contact through my email or my contact numbers. Okay, thank you.